Good evening, Professor. This is my personal timetable. So, in this week, there are the five different type of tasks. The first one is already um, on the progress. So, it's a coronavirus biosensor research article. So me and Prashant discuss before 1 hour that you have given some comments on the paper. So we will uh, consider your comments and do the correction and as well as the add on the necessary things. And the second one is the RF review paper. Sir, we have checked and removed the unplagiarized content. So it's already on the progress, and hopefully in this week we will clarify all the plagiarism reports and finalize the review paper. And third one is the PSA biosensor research. Sir, I have tried 3 times. The last 2 times I got negative values at the step of the graphene or ADC, but today I also again repeat that experiment, so I got the positive results. So I'll explain you the next slide. And the fourth one is Aptamer Biosensor Research. So due to having some busy schedule of the Rionsang and Dongmin, so they didn't join in this research. So in this week, I will plan and make a research plan and to start by this week anyhow. And the first one and the fifth is AAO Biosensor Research. So in this fifth task, we have tried so many steps for the immobilization, and also last week we used the dip coating method for the immobilization. So, I am also looking for the new fabrication because unfortunately we got the negative results during after the LSPR. So we also looking for the next. So this is the new PSA antibody and antigen, as I already told you before. So using these two things to for the further step. So this is my experimental step that I usually follow. So as we already know that this recipe is same as the other PSA antibody antigen. So in this condition, we just skip this spin coating method for the following step, but up to the graphene oxide we follow the spin coating, and the rest of the step we just simply put the drop cast, and we got the positive result as well. Now, so in we have taken the four different kind of chip, and four is a D5 chip, and at the step of graphene oxide, I got this value is a 130.4 picofarad, 138, 123, and 120.8 picofarad. And after that, when I add on the EDC NHS, so I got this result. Is as I compare to the previous one, I got the linear curve and linear values, but and waiting for the antibody because I before half an hour I put the antibody, and according to the biological rule we have to wait for the 24 hours maximum for next capacitance measurement. So waiting for the 24 hours, and then afterwards I will check the value of in terms of this antibody, and after that simultaneously also put the antigen, and tomorrow I will deliver the antigen value as well, both. And so it's a AAO biosensor research is very critical for this, and it's a basic direction where to improve device structure. So we reduce the size of the Ag nanoparticle size. So it's 20 to 70 nanometer to 5 nanometer to coat a 3D nanostructure on AO surface, and also use AO film with large nanopore size is 10 times larger than AO nanoparticle size. An improvement of coating method, because we have tried several coating method like spin coating, like dip coating, and like what we can say drop casting. So we didn't get any positive response after this, so we have tried to look into the new method for the mobilization and quantitative analysis. The content of coated layer accurately size the shifted of LSPR, but optimization also LSPR adsorption as well. So we use this kind of chemicals, and we got MUA chemical also. So as in the place of graphene oxide, we use MUA now. So because why we are using MUA, because it's a triangle shaped 110 nanometer size, and from it's having the best chemical as compared to the graphene oxide. In this case, we have already checked in this paper also, so they use MUA in the place of graphene oxide, but the carboxylic and group is free in the at the same case of graphene oxide. So in this week we've tried with the MUA, and we look into the LSPR result as well. So this is the AO Metasurface research plan, because it's a basic research plan that we followed in the previous PSA and Corona as well. So this is my research plan that I have thinking about this, and simultaneously looking for the characterization of Ag protein complex having clear LSPR adsorption, but also feature shortcoming limiting the sensor application is like weak optical density, always lower 0.5 and a maximum 4, and the widely adsorption band also with flat peak. So we face here problem like to use this kind of complex, so because already the concentration of the this complex is very low, and the problem is second is size. So is a size distribute in wide range. Basically the two things that we stuck, and to solve this as soon as possible, the concentration and the size, particle size, and it's inducing coupled plasma we use for the accurately analyzed particle concentration in the solution. And DLS is dynamic light scattering used to analyze particle size distribution. TEM and mapping used to analyze an element distribution in a film show the result in a colorful figure. So this tip coating method that we followed the last week, but uh, we have seen that the easy to form ultra thin layer with the electrostatic interaction and the silver nanoparticle coated onto the glass using reduced solution has verified. So we found that the Ag concentration is 0.02 milligram per ml, and in the second paper we found that the 1 milligram per ml, but the synthesis is chemical reduction using silver nitric oxide, and the same is green chemical reduction. Coating time is 3 hours, and the other paper mentioned there that 12 hours at a room temperature. So functionalization of glass is NaOH and HCl treated, and here they use Purana or RCA methanol or Aptus. We found that ultrasound spray process optimization of ultrasonic spray coating of polymer films. So we found that the step one is the store the solution in the series pump and put the mask on the substrate, and they set all the components like hot plate, distance between the nozzle and the substrate, and the speed of a spray nozzle. So that there are three things that we have to consider and to go for the second step. So the second step is basically the liquid to be used for coating breaks up to the small droplets by automation the spray nozzle. And the third one is the generated droplets on the substrate then deposited onto the substrate is kept below the spray nozzle where they coalesce to the form a coating. So basically we have to use the spray coating method uh, is the another method that we have to follow and to like immobilization onto the substrate. So spray coating is the another method, but the case is they are temperature controlling as well. So our AO membrane is up to the maximum is 40 degrees Celsius. We have to use this step, so it's very accurate method for the immobilization in our case. And so we found that if there is a gap between the glass and AO, so it's after dropping any liquid on device more than Ag protein complex is penetrated into the AO and to form a thick layer, there is a gap in large. So prove that the Ag protein may not be fixed or an AO or glass surface. So the basically if the use the dip coating or like drop casting or spin coating, so all the Ag content is just submerged or like in between the AO and the glass. It's basically having the 500 nanometers, so quite large difference in between these two layer. And the structure after spin coating on AO's first case is without gapping and the with gap. So without gapping is basically is act like hydrophobic, but the content is basically we use here the graphene oxide because of the graphene oxide having the large flake size. That because of due to having the graphene flakes, the all the Ag content on the protein content is not does not penetrate into the AO nanopore. And the second case is without graphene oxide, which if we consider as the without graphene oxide, all the Ag protein complex is just penetrate into the pore and then submerged onto the glass. So it's like Ag nanoparticle are embedded into the protein layer, and the coated Ag protein layer is thicker than the AO. So the nanopore structure is covered by all the Ag protein complex. An AO film is transferred on the glass is not also stable because of having some air or bubble while the fabrication of the surface. So because if we put the Ag particle, then the air will cover all the content, and the nanoparticle size is 20 nanometer. Fill the Ag protein layer. Ag cannot be observed on the complex layer surface. And as I already told, the graphene oxide flakes is larger than the Ag protein complex. So nanoparticle, Ag nanoparticle is quite smaller than the graphene oxide. And then in the case of without gapping, so the graphene oxide is act like a barrier. So that's why it does not penetrate into the AO pore and fitted into the pore surface. Thank you, sir.